So my name is Carlos. As he introduced me, I'm going to present the work with my colleagues about implementing GDPR for mobile ubiquitous computing. So before starting, I will try to briefly introduce what we name and what is commonly known as mobile and ubiquitous computing. And basically, it's a myriad of inconspicuous and highly specialized internet connect devices. You can see examples such as in the industry with Internet of Things and what we have nowadays commonly used like wearables, smartwatches, and smart homes. These devices or these ecosystems are increasing their adoption, and we can, they estimate in the market that in the next 5 years, we will have around 25 billion devices that will be located everywhere. These devices are characteristically continually collect, analyze, and transmit data on users and their surroundings. However, usually these monitoring practices are often without users' knowledge or consent. So now we have a better idea about what is ubiquitous computing in our work, and commonly in the area of what is the General Data Privacy Protection Regulation, the GDPR. Is a European regulation which has been enforced in May 2018, and it attempts to regulate data collection and processing of personal information. It's basically a set of legal measures to enforce the rights of data subjects, which are individuals that can be subject of monitoring or data collection practices, and penalize and compliant data collectors and processors. I will define later what is a data collector and data processor, but basically they try to protect the personal information or the privacy of users in data collection environments. So as we can see in the web, the GDPR has led to significant changes in these data-related environments. We commonly, or maybe you have experienced that these cookie consent notices that appears in websites. In the case of ubiquitous computing environments, this cookie consent or these consent notices will really hinder the user experience when GDPR applied. For example, wherever you are in a coverage of monitoring devices such as a smart camera, you will have to receive a consent notice to agree for the data collection. Besides these challenges or these issues or that with user experience, there are also several challenges that we will illustrate later to protect users' privacy. As we have been seeing in the previous talks, the data, we collect more and more data, and the privacy threats are like getting more challenging to cover or to protect. In this paper, we first dissect what is the GDPR and the requirements in ubiquitous scenarios, and we propose a system inspired by the state-of-art solutions to re-centralize the data collection under users' control. So, as I mentioned, we will have a brief overview about the GDPR, and we can divide it in two main pillars. One is the rights of the data subjects, and the data collectors and data processors. The first one, the rights, you can see them, I can highlight them like this. Basically, the transparency and consent. Users data subjects should clearly and be informed clearly. They have the right to access any personal information that has been collected by data collectors or these monitoring practices. And they can also rectify or request the complete deletion of the data collected. And also, because there is a consent before like the data collection practices start, they can object to the processing of the data. Now we have what happened in the other part, like if you want to collect data or to monitor users, or so what happened? First of all, we can see on the right what we define data controller. They are persons or business who determine the purpose and way the data is proceed. And data processors are basically persons or that process the data on behalf of the data collectors. So the obligations of data controllers, we can see the data protection by design and by default, the recursive processing activity, such as the monitoring, the collection and processing of data. And in case of security breach, they have to report immediately to the authorities. And also, finally, there is another role in this with these entities, which is the data protection officer, which basically is a bridge between data controllers and authorities such as that every country in the European community will have to control the practices of the data collection and processing. What are the implications and consequences? So to this date, as you can see in the image on the right, there are more like than 900 GDPR fines, and every day there are more and more. Most of the infractions concern data controllers and processors design principles, architectures, and operational practices. 52% of data collection companies are concerned they will submit to the fine, and 65% will change their business strategy due to the GDPR. The 30% finally will increase their budget to implement new regulations in their businesses. And what are the common fines that you can see? I mean, we can have other screenshots in the appendix to show to you if you want in the Q&A. But basically, it's like the storing data forever. That's the reusing of the data, the black markets, which basically sells to third parties with noticing or informing the users at first. Also, the data processing risk, hidden data breaches, which is also common in big companies, and explainability for the for the consent notices, for monitoring requests, monitoring data collection practices, and security. So this is an overall view in the general system environments, but what happened in the ubiquitous system. So first, we can see an example. Like you can imagine, you have a house and there is you install a smart camera. So, or someone install a smart camera, you're a via standard, that can be. So the problem is like this smart camera will collect what they call personal identifiable information, which is any information such as appearance, age, facial features, that is a byproduct of the smart camera collection to avoid burglars. But it's part of the GDPR, the data protection regulation. So in how will you deal with this via standard? They are just passing by the house, and when you want to record a burglar robbing your house. So this is a challenging environment already. And as you can see, we highlight several points, like how to inform the use subjects about nearby monitoring devices, the protection of data subjects' privacy. The ubiquity of devices also present security challenges like tampering or accessing the device hardware. And also the GDPR also requires well-identified data controllers and processors, which in the terms of ubiquitous computing is this line is usually blurred. So here we define, we follow four pillars, like four characteristics, like for improving the GDPR or applying the GDPR based on previous works and state-of-the-art works. And the first one is privacy by design. How can we implement it? There are several works that they try to make specification techniques to facilitate the design and implementation of the GDPR, and they can be used in common or major programming languages. So they facilitate the design, the development using programming languages, applying privacy by design. Then other solution is like privacy enhancing technologies. You stop collecting this personal identifiable information, such as faces. And you can see the example of the previous presentation, like blurring faces already is allowing to protect the data and following the GDPR regulations. So it facilitates the sharing of that data if the face is blurred. Also, there are challenges due to the limit processing of capabilities of smart sensors. So how to deal with this is already complex. And also, there are several solutions. One of them is like edge computing architectures, and they use external parties that can request the processing of the data. So the data is stored locally, this personal identifiable information, and they can request in a query base the data, or data sub, and data subs have the control of the data. In the case of consent, how can we request consent? The most commonly or more general approach is use a companion device. For example, people has a smartphone, so they request when you are in nearby monitoring area of an IoT, for example, or a smart home device, you reduce the fatigue, and there will be pop-up a consent in the smartphone. They will answer, and then there are like techniques to automate similar requests in the future, so the users are not bumped with consent notices every time. In the case of no companion devices, we foresee that natural user interfaces can be used to configure preference in the case you have another way of interacting with the smart device in this case. And for example, one example is cameras and gestures. You can say a gesture to stop recording or monitoring yourself. And or the other words, they try to provide default privacy preference for every bystander in a probably, for example, in a mall, in a public location. Still, in these multi-user or public environments, the difference in privacy preference could be a challenge to implement. Then transparency is like, how can we inform the users about the data collection practices? So they have been papers talking about summarization techniques to summarize these privacy consent notices in a more explainable manner or understandable for the users or for the individuals, in this case, data subjects. And they also have used like SDKs that enables developers to automatically generate these consent notices, like similar to you see in the smartphones with a location request. We can foresee, or this works foresee, the same situation in ubiquitous computing. These techniques help individuals understand the complex and often cumbersome privacy policies involving smart devices and service providers. And due to the as a reflection of our social practices, the collected data to train algorithms does mirrors any possible trace of inequality or discrimination. And that's something the automatization decisions are also considered in the GDPR, and we haven't mentioned before. The artificial intelligence and machine learning techniques applying automated decisions have become exponentially important. Moreover, in the ubiquitous computing, where you can continuously sense myriad of data collection types. In the case of deletion, for example, is already a problem that is not exactly tackled by the GDPR, like they don't agree, but there has been proven works like all the systems that have been trained, like they have some memory regarding the input data. Therefore, there are attacks that can infer personal information about the persons who has been used to train the model. How to solve these problems? One of the solutions is federated learning, which try to diminish the setting of input training using federated learning approaches that also enable privacy enhancing technology to protect more the sharing of information for the training of the machine learning. Although there are still some specific use cases that can be still susceptible of privacy attacks. Zero knowledge proof systems also that verifies information without disclosing any information can be used for this situation and has been applied in several works. And as I mentioned before, edge computing can also be used for this machine learning training. And how in our paper implement the GDPR for mobile and ubiquitous system. So first, there is no one-size-fits-all solution for privacy preservation in a ubiquitous system, let alone implementing GDPRs. Therefore, our solution is just a perspective or like starting to give more ideas for the future research about how can we implement really the GDPR in an efficient way. So for us, we mentioned the smartphone as an interface to privacy, that as they are an intrinsic part of ubiquitous computing, and everyone usually has these companion devices with themselves. And also the increasing computing power for on-device machine learning in smartphones, they are becoming quite, like as you can see with object detection and augmented reality applications. And smartphones are an ideal tool to centralize the user's privacy and implement the GDPR requirement, keeping the personally identifiable information in data subjects control, while allowing the process of information by data controllers. So as you can see, it's a mixed approach with previous state-of-the-art works that they are combined to have like everything into the smartphone. As you can see here, an example, how will the standard work? So for example, the sensors first transmit the data to the smartphone, structured in a machine-readable format. The smartphone then queries a third-party database or the sensor itself to get more information about the monitoring capabilities, what type of data, and also what kind of privacy protection techniques you can apply. The smartphone then privacy protect the data in case it's possible. For example of a face, if it's a visual information, you can easily, it's more easy to apply some rules to obfuscate the faces. In the cases, the rules or the privacy protection techniques are complex or not allowed to do in the device because maybe it's to process the data for a period of time. This set of rules will be embedded as attribute-based encryptions in the shared data. The shared data that will be shared again with data controllers, so they can process and get information they want, while protecting the privacy of users. So the challenges are still even with this implementation is and most of the implementations with the GDPR and ubiquitous computing is the agreement of everyone, every party in the ubiquitous environments to agree, such as device manufacturers and application developers, to deploy this solution or similars. The rules also has to be constructed as policies that all parties, including the users and regulators, should agree on. Due to the additional transmission routes, in our specific use case, real-time application might experience local latencies, and data processors can use different collected data to infer information about the data subject. So despite our approach, it's like our other similar approaches, it's difficult to grasp the capabilities of these the big companies to collect data about ourselves, to infer new data, new information from different sources. And as a conclusion, we expose in this work the challenge presented by the GDPR for upcoming mobiles and ubiquitous applications. The GDPR requirements can contradict not only ubiquitous computing philosophy, but also completely disregard some of the technologies behind ubiquitous computing. We propose this smartphone as an interface to privacy, but this is not a one-fits-all solution, as we mentioned. It's more like a perspective, highlight how can we implement these things. And also, despite the GDPR, there are also similar regulations, such as the California Consumers Privacy Act, that will challenge the ubiquitous computing in a similar manner. And with that, I conclude my talk, and I'm open for any question for the audience. Thank you very much.